Welcome to today's webinar, How to Embed Critical Thinking into AI-Assisted Documentation. I am Sheba and I'll be your host for today's session. Now it's my pleasure to introduce our speaker, Pola Drakopoulou, technical writer at Mitel. With nearly 6 years of experience in technical and content writing, Pola specializes in knowledge transfer, clear communication, documentation quality systems, and content ethics. She transitioned into technical communication after beginning her career as a linguistics research assistant and language tutor. In today's session, she'll discuss how technical writers can combine the efficiency of AI with human judgment to create accurate, ethical, and audience focused documentation. She will also explore practical frameworks such as golden mean for balancing detail and clarity, the Socratic Method for critically evaluating AI generated outputs, and ethical editing to ensure responsible, inclusive, and reliable communication. If you have any questions during the webinar, feel free to drop them in the Q&A box and we'll make sure to address them towards the end of the session. With that, I'll hand it over to Pola. The stage is yours.
Hello, everyone, and welcome. Thank you for being here. My name is Pola, and today I'll show a practical framework for embedding critical thinking into AI-assisted documentation workflows. Okay, at this point, most of us are already using AI in some capacity, and also we are probably sometimes approving AI-generated content because it sounds convincing, not because we have ensured it is accurate, complete, or safe. And that is a gap this session addresses. The question is, I think, no longer whether AI belongs in documentation workflows. The question is, how do we govern it responsibly once it becomes a part of the system? What I want to explore today is how we introduce reusable reasoning into documentation workflows. I'll walk through common AI failure patterns, how the technical writer role is evolving, 3 reusable reasoning frameworks, and 2 real workflows where we applied them in practice. Okay, so without systematic guidance, AI systems tend to fail in predictable ways, many ways actually, some of which also reveal the absence of a structure and oversight. You have probably encountered some of these issues while working with AI, for example, to generate content for your docs. I already saw you mentioned the technical inaccuracies. So first, they may overgeneralize across contexts unless the context is very tightly constrained. Second, they do not inherently reason about security, privacy, accessibility, or ethical impact. And third, they make sometimes or many times unstated assumptions about user knowledge, prerequisite, the environment, and about audience expectations. Okay, in this slide, I decided to leave some room to present a situation I recently found myself in. I ran a small experiment while generating deployment examples with Claude and GPT-4 Mini. I showed the GPT's generated example to Claude and suggested keeping it instead of Claude's own version. And what happened is the model defended its own generation. And then I asked it why. And it answered with a list of things that illustrate that they generated outputs are governed by embedded computational behaviors like familiarity bias. So, for example, it stated that I have a computational preference to keep what is already embedded. Of course, this is one example of behavior, but these things that we observe, they illustrate a broader pattern worth being aware of. And the important point here is that AI systems are not neutral evaluators. Their outputs are constantly shaped by training dynamics, optimization behavior, which means governance cannot rely on confidence or fluency alone. And this connects directly to the traceability problem. So in mature AI systems, governance can be built directly into the architecture through rules, constraints, policies, traceable outputs, but most teams are not operating at that level yet. They still lack built-in guardrails, traceable reasoning, and standardized quality controls. This creates, of course, a very real operational risks. We approve AI generated content because it sounds confident or convincing and not necessarily because it is accurate, complete, or appropriate for the user context. And one practical question becomes, we are not there yet, but what do we do in the meantime? And my argument is that structured human reasoning becomes a governance layer. And the State of Docs report 2026 that explores AI impact on documentation, the future of industry, and much more, reflects this clearly. I find that interesting, so I put it here. AI adoption is high, but governance maturity is low. So the challenge becomes, how do we systematically govern quality, judgment, and risk while AI is already embedded in the workflow? This, of course, changes the role of the technical writer. Documentation quality is no longer only a writing problem, it becomes a systems design problem. Our role shifts from manually producing content or only doing that to also designing and governing the systems that produce content reliably. And that was mainly the mindset shift behind the workflows I'm about to show. And interestingly, industry data increasingly reflects this shift. And this insight came again from reading the recently published State of Docs report. Practitioners are finding that the deeper leverage is not in creating drafts or in the writing itself. It is in the surrounding workflows, such as gathering information from engineering systems, scaling review processes. So the real bottleneck was never only the words, it was coordination, reasoning, review, governance across the workflow. And that realization is what leads to thinking in terms of control layers rather than prompting or using AI everywhere, because sometimes AI simply is not needed or it adds effort rather than efficiency. Okay, we will jump into practical stuff. Here's the challenge we faced with part of our legacy documentation and how we approached it. The documentation set contained outdated terminology, inconsistent chapter quality, and okay, I invite you to imagine a similar scenario you have faced or may face. Let's say you need to review an already published document to remove obsolete references and improve the content. In our case, this separated the work into two different categories: rule based problems and reasoning based problems. So, for outdated terminology, automation was enough. We built a script that scanned the XML source files, generated reports showing obsolete terms, occurrence frequency, and source locations. And that gave us quickly a clear overview and helped us decide the next steps, like which terms to prioritize and what to update or remove. For chapter quality, though, which required things like interpretation, judgment, context awareness, we started with four core questions for the parts or chapters of the document we wanted to improve. We wanted to review them and improve them, having in mind questions like, what is the goal? What assumptions are we making? And is the level of detail appropriate for the user's goal? What could go wrong? And then we made a design move, let's say. We transformed those questions into reusable control layers, or as I call them, frameworks. And we defined three main layers: the golden mean, responsible for checking the amount of information relative to the user's goal and the required level of detail; the Socratic Method, which challenges the assumptions made in the existing content; and the ethical editor, focusing on compliance and accessibility considerations. So, what are frameworks? This is how I call them, but you can call them whatever. The important thing is that frameworks are reusable control or thinking layers. And the key design principle is that if building a governed AI workflow is like designing a system with Lego bricks, then frameworks are the instruction patterns and control pieces that determine how these blocks connect, behave, and stay structurally sound. They encode evaluation criteria, constraints, reasoning patterns, review principles, and because of their nature, they become reusable, implementation agnostic, and portable across prompts, agents, pipelines, YAML workflows, Docs as code systems. So the layers are domain or project specific. You compose them differently depending on what kind of reasoning the task requires. The important thing is to first define the challenge or what do you want to achieve, then step back before using AI to decide whether you should use it at all. And if so, how do you use it? Do you need to add some layers of control? Probably you may have to add some layers because these layers matter. They allow us to shape mental models on responsible, deliberate AI governance, move from using AI to orchestrating it, avoid passive acceptance of output. They can intentionally introduce productive complexity to force deeper traceable reasoning and, of course, take ownership of decisions. In a way, we can say they compensate, at least at some extent, for something we currently may lack: AI systems that can fully explain and justify their outputs. Okay, we are going now to familiarize ourselves a bit more with the frameworks and then see them in practice. So the first framework is the golden mean. The framework, this one evaluates whether the content provides the right amount of information for the user's goal. Too little information creates confusion, too much creates cognitive overload. The goal is always clarity. So this framework's checklist may present this kind of questions. For example, does the level of detail match the importance of the task? Can anything be removed without losing clarity? And these are example questions that the writer makes when working. So we move these into some control layers to the AI tool that assists us, and the output is not an automatic correction. The framework, dependent on how we will design it, simply may flag over-explained sections, under-specified content, and the writer still makes the final decision, for example, to cut, expand, or link out the content. The second framework challenges assumptions. Its purpose is to force the workflow to interrogate context, prerequisite dependencies. For example, about the context, the framework may be designed as such to evaluate what prior knowledge is assumed, what environment is assumed, what happens if a step fails, how the user verifies success. Basically, the main question is what would a confused user ask that this document has not answered? And the framework may identify missing prerequisites, missing validation steps. And again, the framework does not resolve the issues or immediately provide corrected outputs and recommendations. It rather surfaces the issues. So human always remains responsible for interpretation and action. The third framework introduces security, compliance, accessibility, and impact issues. For example, the ethical editor for security and safety may surface unsafe defaults, missing warnings, and for accessibility, if our content is friendly for users with visual impairments, for example. The output may be risk ranked from low to medium or high, and the writer again decides, and the review effort scales according to risk severity. Okay, now let's see them in practice. The first implementation applied these frameworks inside an AI assisted review agent. So we designed an agent that tasks the user to provide a PDF or a text. You can imagine whatever, a text from a Jira ticket, a conference page, or draft documentation, copy paste, really simple, nothing fancy. Then the user would select a mode, review, edit, draft, or question preparation for a subject matter experts interview, let's say. The agent is designed such that it establishes an interactive feedback loop with the writer, capturing intent, target audience, risk thresholds before executing the control layers. Then the reasoning frameworks operate as review layers before output is generated. The result is a structured review report based on our embedded criteria and control layers. For example, in one administrator guide for enterprise, a single sign-on configuration, the agent identified 14 distinct issues, including two high-risk security concerns, unsafe configuration defaults, and missing explanations around privileged system accounts. Other issues were also marked with low or medium. For example, no warning that a mistake that was there can break a live system, or it also mentioned that it was not written for all experience level, and so on. We decided to escalate the high risk issues, and indeed, the decision proved correct because the dev team responded that this has been missed when that content was initially created and should not be there. So that surfaced an issue that would otherwise probably go unnoticed. It was too technical. So yeah, we were not sure that this is correct, the output they gave us, but at the same time, it gave us the opportunity to identify something and make a decision to escalate it. And indeed, that was an issue that needed to be corrected. And probably that also led to avoiding a future ticket. And it was also helpful for junior writers, especially because it helped surface other kind of issues that were previously dependent heavily on senior reviewer experience. And now the frameworks in another practical example. The second workflow, we applied them, is directly into a Docs code pipeline. Docs code is the practice of treating documentation source files with the same tooling, version control, and pipeline approach used for software. The pipeline analyzed raw code changes and generated initial documentation artifacts, three markdown files, one containing documentation impact analysis for the code changes, another a human readable draft explanation of the code, and the third one was a report populated with results from running the drafts through the frameworks. Then it also generated draft source files in data format aligned with the project's existing source structure in two versions. The so-called original version, which represented the first pass output without incorporating review results, and the so-called refined version, which was based on the review outputs. So basically, the second pass translated the review findings into concrete edits and rewrote the data sources accordingly. And of course, again, the final review, validation, and publishing decisions, all that remained with the technical writer. Here you can see a snippet from the review report generated in our workflow. The issues are presented by framework, ranked by low, medium, or high severity, along with an explanation of the issue and a recommendation. And a logical question here might be, how does the tool know how to rank this or what to recommend? But again, it's a job done jointly by both the tool and the writer. All of these elements are refined iteratively and calibrated to our documents, projects, context, goals, and so on. For this specific implementation, also we expanded our control layer by introducing a dedicated information architecture layer, the last one you see. We wanted to see how the system behaves when forced to audit a structural type hierarchy. And the information architecture layer immediately flagged a low severity but important notice. The generated human readable content from the code was mixing conceptual explanation and procedural instruction. So here are the example results for that workflow applied to a 15-line code snippet. So only 15 lines. The report identified three issues, none of them high risk. One of them was that the selected snippet did not include any information on how to validate the expected behavior or how to determine the outcome. In other words, how the user would know if the setting was implemented successfully. And in this slide, you can see part of the content generated in a data file before the review and after running through the review, the so-called refined version, as mentioned earlier. So top of your screen, you can see that before the review, the source file contained one prerequisite. After the review, the refined version, the tool added comments in the source file, identified the two prerequisites, and prompted the writer to confirm information with subject matter experts. So yes, while a senior writer may directly review a human readable draft generated from code and infer these points, such as missing prerequisites or other issues surfaced by the frameworks, adding control layers into our workflows introduces structure not only for the tool but also for us. It ensures that the writer retains ownership of their work and it defines what they want the tool to surface as information, comments, or reminders, and for which specific questions, thereby acting as a valuable assistant. And starting with questions about the problem and the design, and then building a structure that directs outputs toward your specific goals as a writer or as a team is the core of this logic. And when you start like that, it also becomes clearer that not every problem needs AI, or AI in the way you imagined for other problems, or even a control layer. Simple rule-based problems belong in automation. Control layers become necessary when interpretation, contextual judgment, human reasoning become essential to quality. And the practical process becomes identify the type of problem, define the reasoning layers required, if required, design the control flow, automate execution where appropriate. Frameworks sit between first draft and subject matter expert review. They do not replace the style guide, the subject matter expert gate, or the final approval step. They simply add a structured reasoning checkpoint before content reaches those gates so that what arrives there is already hopefully higher quality. And to be clear, these frameworks support reasoning. They do not replace editorial judgment, domain expertise, human accountability. The ownership model remains human centered by design. An advanced architectural benefit of this approach is, I believe, that these frameworks operate bi-directionally. So up to this point, I've shown the frameworks used backward. We generate content first, then audit it with the layers, which are called frameworks. But there's also a deeper architectural move. The same frameworks can be engineered forward as constraints, inside the generation. In other words, the model is not only reviewed by the framework after writing, it can be also guided by the framework while writing. Practically, this means encoding those checks into, let's say, agent policies and validation gates, so failure modes are reduced before they appear in a draft output. In any case, the human is the one who decides and manages how all these are designed. Humans remain responsible for all the important stuff: approval, escalation, publication decision, because in the end, nothing guarantees correctness or fully prevents errors, even when human remains responsible. And this also aligns with emerging best practices. Again, from the State of Docs report, 56% of teams still lack guidelines, and the top practitioners report using semi-automation specifically to ensure the writer has the ultimate say. So closer to the end now, what changed? Outcomes are presented as early observation, as we're still experimenting on lots of these things and refining them. But we noticed that the review became more proactive, more consistent. There was more structure, more scalable. Issues were identified earlier. Junior writers ramped faster, and importantly, the review process itself became more structured, more repeatable. And of course, there are real trade offs to this approach. It introduces indeed some additional effort upfront because you are no longer consuming raw AI output directly. Instead, you are evaluating intermediate layers and checking for correctness. And it also introduces occasional false positives, cases where the system flags or surfaces issues that after human review turn out not to be problematic at all. However, this trade off is justified because it shifts where effort is spent rather than whether it exists. So, in practice, this leads to earlier detection of issues before they become embedded in downstream outputs, more consistent reasoning across reviewers and iterations, and a reduction in hidden failures that would otherwise surface later in the process. Ultimately, it results in a workflow that is less dependent on individual expertise and more on structured evaluation. And as you know, the better the observations you make and use to train or refine the system, the more targeted and effective the assistant becomes for your product, your documentation, and so on. And at this point, I want to mention that there is also a less visible but important gain, a behavioral shift. This approach changes how you interact with AI systems because it encourages a more deliberate stance, not just accepting outputs, but evaluating them, questioning them, and making explicit decisions to approve, revise, reject. And over time, this becomes a habit of critical engagement rather than passive consumption. And that habit is itself one of the most important outcomes. Another statistic, the last one for this presentation, but this one stood out to me, was that 64% of respondents believe AI will be extremely impactful. And it caught my attention because I believe we all know that the impact does not come from tooling alone. Efficiency gains only scale meaningfully when organizations invest in the upfront work of defining structure, expectations, reasoning standards, and governance. And clearly, there's still a gap between belief in impact and actual guideline adoption. And that was really the purpose of this presentation, to explore how we design what we actually want AI systems to produce rather than simply relying on what they generate. Until AI systems can fully explain and justify their outputs in a traceable way, linking answers to rules and validated sources. And even then, responsibility for reasoning and judgment remains with us. So the control layers I discussed are specific to documentation, but the underlying logic can be adapted across contexts. The core idea I want to leave you with is this: let's not just use AI to move faster. Let's design how it is allowed to think within our systems. You can pick one document you're currently reviewing, run it through a structured checklist before you publish it, experiment with the mindset of a designer, not just a user, because I truly believe the real safety is not in how we use AI tools, but in how deliberately we design the systems around them and the curiosity with which we approach them and what we learn from that process.
Thank you, Pola. And that's a wrap for today's session. Once again, a huge thank you to you for walking us through the
Thank you.
topic. To everyone who tuned in, thank you for taking your time to be here and for all your great questions and comments. And of course, if you have more questions or want to learn more about Document 360, then feel free to reach out to us. We'll be back soon with another session. Until then, see you next time.